In this video, we're going to take a look at reviewing the homework from differential equations, and I wanted to work some of the problems for you so you could make sure that you understand what you're doing. So on this page, we began with number 37, so I'm going to do that one first. Remember, when you're solving a differential equation, the steps are separate, number one. So the first thing I'm going to do is I'm going to separate the variables by multiplying dx to both sides. And so when I multiply both sides of the equation by dx, I will get 3x squared dx on the left-hand side. Step 2 is to integrate. So we separated, and now we're going to integrate. Remember, there's an understood 1 here, and we're finding the antiderivative of 1 in terms of y, so we get y. On the right-hand side, when we find the antiderivative, we're going to use the power rule. So we're going to increase the power by 1 and divide by that new power, and then we're going to have a plus c. So that one's pretty easy and pretty straightforward. All right, let's take a look at number 39. Let me just undo that. Edit, 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 undo, and erase that. Next problem is number 39. So the steps are to separate, integrate, and solve for c if possible. None of these have an initial condition, so we're going to then solve for y. Alright, so let's grab the pen here. Number 39. So I'm going to multiply both sides by dx, and I'll get x over 1 plus x squared dx. And so when I find the antiderivative on both sides, this looks like a u substitution problem because I can't algebraically simplify, so I'm going to let u equal to the denominator, and then du is equal to 2x dx, and I do not need that 2, so I'm going to get rid of that. And so when I make my substitution for the right hand side, I will have a 1/2 in the front and a 1 over u du, which is going to give me 1/2 ln absolute value of u. And so over here on the right hand side, when I find the antiderivative of 1, I get y. On the left hand side, when I make my resubstitution, I will get 1/2 ln absolute value of 1 plus x squared plus c. Alright, so that's number 39. Next problem we're going to look at is number 41. Let me get this erased. Alright, number 41. In number 41, I'm going to separate the variables, so I get dy equal to x minus 2 over x dx. I'm going to find the antiderivative on both sides. Well, in just a second, I'm going to do my algebra simplification. I'm going to divide both terms by x, so I get 1 minus 2 over x dx. On the left-hand side, I'm just going to get y, and on the right-hand side, I get x minus 2 ln absolute value of x plus c. Moving on, let's just do this instead of erasing. Number 43. Separate the variables. I get dy equal to sine 2x dx. I have an inside function, so I'm going to let u equal to 2x. du is equal to 2 dx, and I do not need that 2, so I'm going to divide that out. So I'm going to get 1/2 sine of u du. And when I find the antiderivative of sine, the antiderivative of sine is negative cosine of u plus c. And so when I find the antiderivative on both sides, I get y equal to negative 1/2 cosine, put my replacement back in, 2x plus c. Moving on to number 45. Looks like a stubborn x problem, we'll see. So dy, multiplying the dx to the other side. Find the antiderivative on both sides. Let me make some space here. Going to do a little u substitution. Don't forget all of your antiderivative strategy. So I'm going to let u equal to x minus 3. du is equal to dx. And x is equal to u plus 3. So there's my stubborn x replacement. So when I do, let me make a little more room down here. When I do my u substitution, I will have, in place of x, u plus 3. In place of x minus 3, I'll have u to the 1/2 power du. Distribute that, and I'll get u to the 3/2 plus 3u to the 1/2 du. Using the power rule, I get u to the 5/2 multiplied by 2/5, and I get 3u to the 3/2 multiplied by 2/3, so that will just give me a 2. So on the right hand side I get on the left hand side, and on the right hand side I get 2x minus 3, making my replacement for the u substitution, over 5, plus 2, making the other replacement to the 3/2 power, and then my plus c. And let's see what's going on. 47 is the last one, another u substitution problem. So when I separate, I get dy equal to x e to the x squared dx. I'm going to let u equal to the power, which is x squared. du is equal to 2x dx, and I don't need that 2. So when I do the u substitution, I'll have a 1/2 out front, and I'll have e to the u du, which is e to the u over 2. So I'm going to do my anti-differentiation. I get the y, and I'll have e, make my replacement back, x squared over 2 plus c. Alright, so those are pretty easy, hopefully. I hope you found those to be easy as well. Now on the next page, we are going to have x's and y's mixed up. So let's take a look on this page. We did 1 through 7 odd, so let's work each of these. Number 1, when I separate the variables, I'm going to multiply the y to the left-hand side, and I get y dy, and I'm going to multiply the dx to the other side. So there's my separate, and then I'm going to integrate. On the left-hand side, I get y squared over 2. On the right-hand side, I get x squared over 2 plus c. Solving for y, I get y squared equal to, multiplying both sides by 2, and I know this is going to bug you a lot, but 2 times c is just c, and then if I want to get y by itself, I get plus or minus the square root of x squared plus c. Let's go on to the next one. Number 3. When I separate, I'm going to move, let's see, I'm going to keep the 0.05 on the right hand side. I think it'll make it easier. So I'm going to divide both sides by r and get dr over r equal to 0.05 s. I'm going to find the antiderivative on both sides. On the left hand side, I'm going to get ln, absolute value of r. On the right hand side, that was a ds up here. On the right hand side, I'm going to get 0.05s, and solving for r is going to give me r equal to e to the 0.05s, and I forgot my plus c over here, plus c, which is r equal to c e to the 0.05s. Remember in class we talked about how to, I algebraically showed you how this becomes this. So go back and take some time if you're confused by that, and review your notes. Number 5, we have 2 plus x times dy dx is equal to 3y. I'm going to multiply, first of all, the x to the right hand side, just to kind of do this step by step. And notice that the x's and y's are not together yet, so I'm going to divide both sides by 2 plus x and both sides by 3y. Actually, I think I'll leave the 3 on the right hand side and just divide by y, so I'll get dy over y is equal to 3 times 2, whoops, I'm dividing, sorry. Come on. So I'll get 3 over 2 plus x dx. Let's see, what am I going to do now? On the left hand side, I know what I'm going to do. I'm going to have ln, absolute value of y. On the right hand side, I think I'm going to do some u substitution. So u is equal to 2 plus x. du is equal to dx. So I'll have 3 out front. I'm just multiplying that out in front. 1 over u du. 3 ln absolute value of u. So when I make the replacement, I will have 3 ln absolute value of 2 plus x plus c. Alright, let's get through the algebra here. Give myself a little more space. Alright, so that's going to be y equal to e to the ln of 2 plus x to the third power plus c. So that's going to be y equal to e to the ln of 2 plus x to the third power times e to the c. E and ln undo each other. So I get y in e to the c, remember, is just c. So I get c times 2 plus x to the third power. And then I have one more somewhere up there. Let's clear the board here. That got rid of my problems. So let's just erase and make some space for the last one. So the last one they have to do is number 7. And after this, I'm going to go back I'm going to let you look at some of the application problems that you did as well to see how you're doing with those on the differential equations. Okay, grab a pen here. Number 7. So we have y dy dx is equal to sine x. I'm going to multiply the dx to the other side. I just lost my dy, sorry about that. So I have y dy is equal to sine x dx, and I actually think you can finish this one up yourself, so that one's not too bad. Alright, let's go on and take a look at the page 440. I forgot about that. And I think what I'm actually going to do for page 440 is actually post these answers so that you can look at them at your own pace instead of me trying to explain each one of them here. So I will post those on Edline for you. All right, let's go on to the application problems that I had asked you to do. I asked you to do problems number 1 and number 2. So in this problem, you have Chet and his baseball card collection. They give you an initial condition, and they tell you that the value of the initial condition, the value was $25,000 10 years ago, and its present value is $35,000. Write a differential equation to model the value of the collection and solve the differential equation. So if you come down here and look at my work, notice that I recorded that the initial condition at time 0, the baseball card collection was worth $25,000, and 10 years later, the baseball card collection was worth $35,000. So in this case, they told me that, let's go back up to the problem. They tell me that his baseball card is increasing, and they tell me that the rate of appreciation is, there's my equal marks, proportional, there's my K, to its value at that time. So let's see if my equation down here agrees with that. So I said the rate is proportional, there's my constant of variation, to the value at that time. So that's how we write the differential equation. And then in part B, I'm going to separate the variables, get the V's on one side and the K's on the other. Then I'm going to anti-differentiate on both sides. Remember, the steps are separate, integrate, solve for C, and then solve for K. In this case, I actually solved for V first by using log properties. So that's what happens when I find the value of his collection. The way that we got the 25,000, the initial condition is 25,000. So if you substitute 0 in place of T and 25,000 in place of V, you find out that C is equal to 25,000. So that's your equation. Then to find the value of K, we're substituting the second condition that was given. So the value of the card collection was 35,000 10 years later, so I'm substituting 35,000 in place of V and 10 in place of T. Then I divided both sides by 25,000 to get 7 over 5. Then to get the 10K down, we're going to take the ln of both sides. And remember, ln and e undo each other. That's why it's not really disappearing. We're doing inverse operations. And then solve for K by dividing both sides by 10. And then I use my calculator to turn that into a decimal approximation of 0.034. Put that back into the equation. And then they wanted to know, I think in part C, when the value of the collection would be double. So if the initial amount was 25,000, double that's 50,000. Divide both sides by 25,000, and that's where you get the 2 from. Take the ln of both sides to get the power down. Divide both sides by the coefficient, and then use your calculator, and you get 20.387. And the reason it's 10.387 is because 10 years have already expired, so this is the other 10.387 years. In problem number 2, you've got a guy who has problems with mold in his shoes. So it says the rate, here's my rate, is, there's my equal marks, proportional is my K, to the amount of mold in the shoes. And so from there, we're going to separate the variables. So I got the m's on one side, I left my K a constant on the other side. I took the antiderivative on both sides. I used log properties to get m by itself. I substituted the initial condition at time 0 there were 3 grams of mold, and then later there were 7 grams of mold on, I guess, day 2. Use log properties to get the 2K down. Divided both sides by 2. Substituted back into the original equation. And then in letter C, I used that to predict the amount of mold that there would be on day 10. So pretty straightforward. Hopefully you found it to be that way also. Any questions that you have, you can get ready to ask me a little bit later. So that's a review of the homework. Let's see if there's anything else here. That's what I'm going to ask you to do today. So, got any questions ready that you have? Bring them back to school when I see you. We'll go over those.